Hello everyone, hope all of you are doing well. In the previous video we have discussed the questions and numericals from the portion distance, displacement, speed and velocity. In this video we are going to discuss the textbook questions related to average speed, average velocity, acceleration, etc. Are you ready to go with the first question? The question is from page number 102 and the question number is 2. The question is, under what conditions is the magnitude of average velocity of an object equal to its average speed? Before going to answer this, we have to know what is average velocity and average speed. Right. We have average speed is equal to total distance travelled divided by total time taken, and average velocity is equal to displacement divided by total time taken. In this case, the denominator is the total time in both cases. So, to get the same average speed and average velocity, the distance and displacement should be the same. What is the condition for getting same distance and displacement? Yes, we know that when the object travels in a straight line, both distance and displacement will be the same. In such a case, average velocity will be equal to average speed. In our exam point of view, no need to write all the explanations. I just mentioned this to understand the concept. We have to write only like this, that is, the magnitude of average velocity of an object is equal to its average speed only when an object is moving in a straight line. Okay, hope it is clear to you. Next is question number 3. The question is, what does the odometer of an automobile measure? You all might be familiar with the odometer in automobiles, right? So we know that the odometer of an automobile measures the distance covered by an automobile. Next is question number 4. What does the path of an object look like when it is in uniform motion? What is uniform motion? If an object covers equal distances in equal intervals of time, it is said to be in uniform motion, right? The object having uniform motion has a straight line path. So when we answer the question, we have to mention only the straight line path. No need of the explanations. Okay. Next is question number 5. The question is, during an experiment, a signal from a spaceship reached the ground station in 5 minutes. What was the distance of the spaceship from the ground station? The signal travels at the speed of light, that is 3 into 10 raised to 8 meter per second. When you are getting a question, that is a numerical problem, you have to read the question clearly and write down the quantities given there. So in this question, which all quantities are given? First of all, we have the time, right? So time is given as 5 minutes. So first check that is it in SI system. What is the SI unit of time? That is second, right? So that we have to convert this 5 minutes into seconds. So how we will do? We know that 1 minute is equal to 60 seconds, right? So we can multiply this 5 with 60. That is 5 into 60, that will be equal to 300 seconds. So that time we have written here. And after that, which all quantities are given? The signal, it is given that the signal travels at the speed of light, right? So that the speed is given as the speed of light. So that also we can mention speed is equal to 3 into 10 raised to 8 meter per second. And which quantity we have to calculate? That is, we have to calculate the distance of the spaceship from the ground station. Okay, so we have time, speed, and we have to calculate distance. Can we connect these three quantities? Do you know any equation connecting these three? Yes, we have speed is equal to distance by time. Okay, so that we can cross multiply to get distance. Distance will be speed into time. Okay, so that we can substitute the values. Distance will be equal to speed into time. Speed is given as 3 into 10 raised to 8 meter per second and time 300 seconds. So we can just multiply, that is 3 into 10 raised to 8 into 300, that is equal to 9 into 10 raised to 10 meter. So that is the distance. Hope it is clear to you. So first of all, you write the correct units, then only you will get the proper answer, and don't forget to write the unit for the last answer also. Okay. The question is from page number 103. The question is related with acceleration. The first question is, when will you say a body is in uniform acceleration? Second part, non-uniform acceleration. Before answering the question, you have to know what is acceleration. You all might be familiar with the word accelerator, right? What happens when the driver applies accelerator? The speed increases. Actually, the literal meaning of acceleration is increase. Acceleration is the rate of change of velocity. That is how velocity changes with time. When velocity changes, there will be acceleration. Or we can say that acceleration exists only when there is change in velocity. Consider an example. Assume a car travels at a speed of 80 km per hour in a straight line. Will there be acceleration? No, because here the velocity is constant. We can consider one more example. Suppose the car is starting from rest and travels with a speed of 50 km per hour in a straight line. Will there be acceleration? Yes, because the car has a change in its velocity. That means initially it was 0 velocity and it has increased to 50 km per hour. Okay, and one more example. Assume that the car is moving with a speed of 40 km per hour and moves towards right with 40 km per hour. Then continue with the same speed. Will there be acceleration? Yes. As the direction is changing, the velocity will also change. Velocity is speed with direction. That is why the acceleration is there, because whenever the direction is changing. Okay. And we can calculate the velocity by using the equation. Acceleration is equal to change in velocity by time. That is A is equal to V minus U by T. Here V is the final velocity, U is the initial velocity, and T is the time interval. Okay, so that by using this equation we can calculate the acceleration. Hope the acceleration part is clear to you. Now we can answer the question. Okay, a body is said to be in uniform acceleration if it travels in a straight line and its velocity increases or decreases by equal amounts in equal intervals of time. And in the case of non-uniform acceleration, a body is said to be in non-uniform acceleration if the rate of change of its velocity is not constant. So that is the difference between uniform and non-uniform acceleration. Now we can move to the next question. Question number 2. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. Now look at the question. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. What does it mean? The initial speed of the bus was 80 km per hour, that is U is equal to 80 km per hour, and the final speed is 60 km per hour, that is V is equal to 60 km per hour, and time interval is given as 5 seconds. Okay, we have to calculate the acceleration of the bus. Now, first of all, we have to convert this kilometer per hour into meter per second. Okay, for that, how we can convert this kilometer per hour into meter per second? 1 kilometer, we know that because 1 kilometer per 1 hour, that we have to calculate. 1 kilometer is 1000 meter, right? Divided by, how can we write 1 hour? 1 hour is 60 minutes into 60 seconds. So that will be 1000 divided by 3600. When we cancel the zeros, we will get it as 10 by 36. Okay, so that will be 5 by 18. So this 5 by 18 is always a constant. So whenever we want to convert kilometer per hour into meter per second, we can simply multiply by using 5 by 18. Just remember this quantity, 5 by 18. Okay, now we have to convert u, that is initial velocity speed, into meter per second. That is 80 is equal to 80 kilometer per hour is equal to 80 into 5 by 18. That is 22.22 meter per second. Now in the same way, we have to convert the final speed of the bus into meter per second. That is 60 kilometer per hour, that is equal to 60 into 5 by 18. That is equal to 16.66 meter per second. Now the time taken is given as t is equal to 5 seconds. We have to find acceleration. What is the equation for finding acceleration? A is equal to v minus u by t, that is change in velocity by time. We can substitute the values here because we have v, u and t. So v is 16.66 and u is 22.22. So that values we are substituting here. A is equal to 16.66 minus 22.22 divided by 5. So that will be equal to 1.112 meter per second square. So in some questions, the values will be given in kilometer per hour. So in such cases, we can convert into meter per second by multiplying with 5 by 18. So just remember that thing so that it will be very easy to calculate. Okay. Now we can move to the third question. A train starting from a railway station and moving with uniform acceleration attains a speed of 40 km per hour in 10 minutes. Find its acceleration. So look at the question. What are the things given here? A train starting from rest. Okay, here the train is starting from rest. That means whenever an object is starting from rest, the initial velocity will be 0. So we can write u is equal to 0 in this case. And it moves with uniform acceleration, attains a speed of 40 km per hour. That means v is equal to 40 km per hour and time is given as 10 minutes. Okay, find its acceleration. We have to calculate its acceleration. Now we can write down the quantities given here, that as the train is starting from rest, u is equal to 0 and final velocity is given as 40 km per hour. So that this 40 km per hour we have to convert into meter per second. We know that to convert kilometer per hour into meter per second, we have to multiply with 5 by 18. So that we will get v is equal to 40 into 5 by 18. The answer is 11.11 meter per second. And the time is given as t is equal to 10 minutes. So this minute also we have to convert into seconds, right? How we will convert that? 10 into 60. Okay, so that we will get 600 seconds. And what is the equation for finding acceleration? A is equal to v minus u by t. That when we substitute the values, we will get 11.11 minus 0 divided by 600. So the answer is 0.0185 meter per second square. Hence the acceleration of the train is 0.0185 meter per second square. Hope it is clear to you.